So, we are looking at the notes on Pythagorean theorem. Shh. Pythagorean theorem practice worksheet. The Pythagorean theorem relates the side lengths of right triangles and right triangles only. To understand the relationship, you need to understand how sides are named in a right triangle. The side opposite of the right 90-degree angle is called the hypotenuse. The other side opposite the acute angle in the triangle are called the legs. For example, these are legs. This is the hypotenuse. Pythagorean theorem is widely attributed with describing the relationship between the legs and hypotenuse of a right triangle as a squared plus b squared equals c squared, where a and b are lengths of the legs and c is the length of the hypotenuse. Another way to think of this is that leg 2 squared plus leg 2 squared equals hypotenuse squared. So for this case, 5 squared plus 12 squared equals hypotenuse squared. 25 plus, this is exactly our warm-up. 25 plus 144 equals the hypotenuse squared. I'm going to move this in a little bit. Move this out of the way. There we go. All right. So 169 equals hypotenuse squared, square root, we get 13. Don't forget that to undo squaring something, you have to take the square root. Sometimes answers will be given in radical form, square root form. For instance, hypotenuse squared equals 3 squared plus 3 squared. So 9 plus 9 equals hypotenuse squared. Hypotenuse squared equals 18, square root. So if we take the square root of 18, if we put it in our calculator, it gives us a decimal, right? And it's really long decimal. So instead, we're going to make it in simplified form. So what two numbers multiply to give us 18, where one is a perfect square? Do you guys know your perfect squares? So like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. I'm writing these down for you so that you guys have them. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169, and so on. Okay? So we have an idea. So when we talk about 18, what number goes into 18 evenly where it's a perfect square? The answer is 9, right? So we go 9 times 2, and then the square root of 9 is 3. So 3 square root 2. So this is in radical form, where this up here is just in regular form because it reduces, like it is a perfect square. Okay, so we're going to separate factors, the numbers, into perfect squares. Numbers that are integers multiply themselves. And here are some examples below. Now do the practice problems on the back. Don't forget to show your work. So we're going to do some of these together. 1 and 2 are done for you. Okay, 1 and 2 are done for you. 3 squared is 9. 4 squared is 16. That gives us 25, so the square root is 5. This one, do you guys see that this is a leg? X is a leg, that's why it's there, and it's not equals x. So we go x squared plus 4 squared equals 12 squared. X squared plus 16 equals 144. Subtract 16 from both sides. X squared equals 128. Take the square root of both sides. Then 128, the number that goes in there evenly is 64. So it's 64 times 2. Square root of 64 is 8. Okay, so let's do another one together. Which one is our C? Which one is our hypotenuse? 13. So that's what it's got to be equal to. So then we go x squared plus 4 squared. Could I have gone 4 squared plus x squared? Yeah, you get the same answer. Because you can, 2 plus 4 is the same thing as 4 plus 2. Equals 13 squared. Okay, so we're going to get x squared plus, what's 4 squared?
16.
And what is 13 squared again? 169. Now what am I going to do? Subtract the 16. And we get x squared equals what? What's 169 minus 16? 153. And now we have to do the square root of 153. This is why I left the calculator cabinet open, because when we get to this might be a problem. What number goes in perfectly for 153? So we're thinking of it like, okay, we know 13 doesn't. 12, does 12 go into 153 evenly?
Not evenly, it's got a decimal there.
No, they've got to go in evenly.
I don't think it goes in there. Only anything goes in there. I think it's a prime number.
So if we go 153 divided, 3 doesn't help us, but 9 might. 9 goes in there evenly. Yep, 17 times. So x equals the square root of 9 times 17. Then we can say, what's the square root of 9? 3. So x equals 3 square root 17. Does that make sense? That's how we are going to be reducing radicals like that. It's a little bit harder. Of course, I will, if you left it as x equals the square root of 153, I wouldn't mark you down on this homework. But we need to begin to work on being able to break them down before the next quiz and stuff. Okay? So let's try number 4. Which one is C for number 4? X. Okay, so I'm going to go 4 squared plus 6 squared equals x squared. 4 times 4 is? And 6 times 6 is? 36. Okay, what's 16 plus 36? 52 equals x squared. Now we have to find the square root of 52. It's not a perfect square, right? So what number do we think goes into 52 evenly? 4. Yep. So we get the square root of 4 times 13 equals x. So we get 2 square root 13 equals x is our answer. Oh, I'm sorry. Thank you. What do you think, guys? Should we do one more, or you think you're okay doing your homework? One more? Okay. What is C for number 5? 15. I heard somebody say they couldn't read it, so I'm trying to turn. Is it because it's too small or because my handwriting is so bad?
Too small.
Okay. All right, so we're going to get x squared plus 6 squared equals 15 squared. Okay. So we're going to get x squared plus, what's 6 squared? And what's 15 squared? 225, nice. So we're going to go 225 minus 36, and we get x squared equals 189. You guys okay with me not doing minus 36 to both sides?
Yeah.
You'd rather me do it in there? Okay. I minus 36. That's how I got that. Okay? Now we need to find the square root of 189. So I'm going to square root both sides, and I'm going to get x equals something. So let's try this. It's not a perfect square. Let's see, what might go into this evenly? We think 189, 9 might go in there evenly? It does. So x equals 9 times 21. And there's no perfect square that goes into 21, right? Just 7 and 3 go in there, neither of those are perfect squares. So I get x equals 3 square root 21 is my answer. How are we feeling about these? Can you use these as an example? This is enough to do your homework tonight? Okay. All right. Now we are going to do a quick little review before our performance task. So I am going to do patty paper first. What shape would you guys like me to do on the patty paper? Yes. Okay. Okay. Yes. All right. So I'm going to zoom this out so you guys can see a little bit better. And then turn the light back on here. Okay. So I'm trying to find a blank background because it shows it better, but I might not have one. Here we go. Okay. So here's my piece of patty paper, and I need to make a kite. The first thing I'm going to do is draw a straight line. Okay? Everybody's got a straight line on their patty paper. This is practice. You can go over it with me and get a new piece of patty paper if you want. That's what I strongly suggest that you do. I have one more compass up here, by the way, if anybody needs it. Okay, so then I'm going to fold this in half. I'm going to make sure the line goes directly over my other line. And I want it to be perpendicular. Okay. Now, all I'm going to do is I'm going to draw just a little bit on the top. And I'm going to draw it longer on the bottom. Do you guys see that? So, after I folded it in half and I made that crease, I traced the crease, but I didn't trace the whole crease. I just went a little ways to the right of it and a long ways to the left of it. Does that make sense? Okay, now all I'm going to do is I'm going to connect my endpoints. And I have a kite. Done. So, what I knew is I knew kites have perpendicular diagonals. I know this small line should be bisected, should be the same on both sides, cut in half. And then I know their other diagonal is short on top and long on the bottom, right? Or like this, short on top, long on the bottom. So that's what I did. We're done. Okay, mirror. What shape do you want me to do with the mirror? Isosceles trapezoid? Sure. Okay, we start everything with a straight segment. Now I'm going to create parallel lines. In order to do parallel lines, I'm going to look through my mirror. And, oh, it kind of shows up pretty good here. See how I see that line right there? See how I see this shadow of a line right here? Yeah. I'm going to trace that, except I'm going to do it larger. So I'm going to make sure it's parallel. Ooh. Okay, so I've made that, right? Now I'm going to put my mirror here. I'm going to draw a line connecting these two first. And then I'm going to put my mirror here. And I'm going to trace it. Okay, so I just want to put little dotted lines where I put my mirror. I put my mirror first here to make parallel lines, and then I put my mirror here to copy that line over. That's it. Isosceles trapezoid. I suggest you will get more points on this when you do your mirror part if you put a dotted line wherever you put your mirror. Okay. All right, next. We've got compass. What shape would you like me to make with a compass? A square? Sure. Okay. So whenever we do anything with a compass, we always start with a what? A line. Or a segment, really, because lines go on and on forever. So here's my segment. Okay? I'm going to take the pointy end of my segment, put it on the end point of the segment, and make my compass more than halfway. Everybody with me so far? I'm waiting. We with me?
Yes.
Okay, now draw an arc. Okay. Now I'm going to pick up my compass. I'm going to put it on the other end point of my segment, and I'm going to draw an arc. Okay. Now here's the tricky part. So we're good so far there. We've made perpendicular lines. I'm going to put a very light line here. Put it really light because we're going to have to erase some of it. Or change the length of it. So right here, I've bisected the original segment that I made. So I'm going to measure it. I'm going to put the pointy end in the middle, and I'm going to put the pencil end on the end point of the segment. And then I'm going to make a mark all the way around. I'm going to kind of draw a circle. Okay? These, my circle intersected here, 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 and here. That makes all my diagonals equal. I've made my diagonals perpendicular, and I've made each of these equal. If all of those are equal and 90 degrees, it does create a square. So I'm going to connect these. I put the pointy end in the middle, and I measured it to one side of my segment. Okay? So watch this. See, when I'm creating this, look, I didn't even have to worry about 90 degrees, but that made 90 degrees right there. So I have created a square. Done. I know it looks like a diamond, but look, when I turn it this way, you can see that those are all 90 degrees.
Is that a rhombus?
Now, a rhombus, the only difference with a rhombus is that when I made this, this side would have to be longer. So I would have to make a point like here. And then when I make it, it would be bigger. Here, I'll do it in a different color. I'll do it in blue. So literally, if you made a rhombus and not a square, it means you didn't measure your diagonals correctly. So this is our rhombus in blue. See how that works? The only thing I did was I measured that this half and this half was the same, but they were bigger than this half. See how it's bigger? That's all. Okay? I think kites, squares, rhombuses, those are the easiest things to make with a compass. Because you're just making perpendicular lines and then just adjusting it. Like for a kite, right? How would a kite be different? I would have made this longer, and then I would have attached these. Right? That's the only difference. So I've kind of showed you how to make a square, a rhombus, and a kite. Which I said I was only going to make one, so I cheated. Okay. So, ladies and gentlemen, I now need you to put all your phones up here. You will not be getting those back till the end of the hour. And then we're going to take this quiz.